This is AS2 Physics 2 Jun2008, question 3. A resonance tube and a number of tuning forks of different frequency are used to determine the velocity of sound in air by locating the first resonance position for each tuning fork. For the first or fundamental position of resonance, the length of the air column in the tube is L. Figure 3.1 shows a typical arrangement. So this is exactly the same as the last question, and this is really how you should label this: tuning fork, resonance tube, air column, I didn't label in the last one, water, and then the length of the tube. On figure 3.1, mark the positions of the node and the antinode in the air column. Now, I would definitely draw in the standing wave, and to do that I'm just going to turn this on its side just to draw this in, and it is something like this. Okay, so that's the standing wave. Just turn it around again, and again it's a quarter of a wavelength. And so I'm going to put that the node then is going to be where there is a null position or no movement, and that's down here. And then the antinode is going to be at the open end, at the other end is up here. How would the experimenter know that resonance has occurred? Well, they would know because they could hear loudest sound, and that's how they would know. State the relationship between the resonant length and the wavelength of the sound. So if we look at this diagram and what I've drawn, here we have a quarter wavelength, and so that L that you measure is equal to a quarter of a wavelength. So L is equal to lambda over 4, or you could rearrange that to say lambda was equal to 4L. Hence show that 1 over f equals 4L over v, where v is the velocity of the sound. So if we write down v is equal to lambda f, and lambda is 4L. Now it's suggesting 1 over f, so if we bring this to the other side, or in fact if you want to turn everything upside down, 1 over v is equal to 1 over 4L by 1 over f. But this is going to be the can't see that. V is equal to lambda f, lambda is 4L. If we say 1 over everything, you end up with this. But this is going to be the subject of the equation, so we have to bring this over to the other side. And so that will multiply. So 4L over V is equal to 1 over f. And you've proved that equation then. You've proved what you have to prove there. Next part of the question. A typical set of results has been used to plot the graph in figure 3.2. Use this graph and the relationship in C part 2 to obtain a value for the velocity of sound. If I just scan out a wee minute just to see. I think that's it the whole way out. Maybe not. Okay, I'm scanning again there. That's as far out as it goes, I'm afraid. It's quite a big graph. So there you can see the graph. You've got 1 over f. You see there, by 10 to the minus 3 seconds, and it is against L. So our relationship again was 1 over f was equal to 4L, and I'm going to multiply, no, I'm just going to put over V, and then I'm going to split that up. That's 4 over V times L. And if I write y equals mx underneath it, y is equal to, and this is what is on the axis, so that's x and that's m. So the gradient of your graph gives you 4 over v. And so the gradient of the graph then, when you calculate that, you have to show, I'm going to scan out again here, you have to show that the gradient, you have to draw a triangle bigger than 5 centimetres or they won't give you the marks. So draw a good big decent triangle. I'm going to go from here right down to the 2.7 to there. Okay, so I'm going to go down to there. So that's definitely bigger than 5 centimetres. Otherwise, they're not going to give you the mark for showing that, because these are nice, easy places to draw the triangle and work out what the marks are, or what the readings are. So this one here is going to be 3.62. And the bottom y value then is going to be 2.7. And that's by 10 to the minus 3. And then on the bottom along there we've got 300 minus, and it's 224. So that gives you 0.0121, but we know that this is equal to 4 over V. So V is equal to that divided by 0.0121. And whenever you do that, V actually comes out very well as 330. And that's your answer, 330 metres per second.